In today's lesson, we will begin working with a quadratic equation. Quadratic equations are the main topic of second semester algebra. So we'll be doing a lot of different things with quadratic equations. However, in this lesson and this unit, it's only an introductory of quadratic equations and how you go about solving them. In this lesson, we'll be talking about a lot of the different terminology so that when we use it throughout the unit, you understand what we're talking about and what we're referring to. A quadratic equation will be an equation where the variable has an exponent of 2. That means there's only one variable in the equation, and then the largest exponent is squared or 2 to the second, something to the second power. When we write an equation that is quadratic in standard form, it's going to look like this right here. Notice that I have my highest degree equation or exponent right here with 2, followed by my x to the first power, and then the last number that is written is my constant, my c value. As you recall from previous lessons, a constant is a number that does not have a variable connected to it. One of the most important things you need to understand about standard form of quadratic equations is this 0 right here. Quadratic equations are not written in standard form unless they are set to 0. And that 0 is very important when we're solving the quadratic equations because we can't use the quadratic formula and we can't factor if we have any number other than 0 on the right side of the equation. Now, when we graph a quadratic equation, we are going to get a parabola. The parabola is a U-shaped image that is formed on the graph, and it is actually symmetrical. The points are, other than the vertex, all the points on that parabola are going to be symmetrical or equal distance from the vertex. And we'll discuss that later on throughout the unit and the units to come as we begin working with them. The lowest point on the graph is the vertex, and that's actually like the point of the parabola. Now, the solutions to the quadratic equation, and that's what we're looking for when we're solving quadratic, we're trying to find the solutions. These solutions are also known as zeros, roots, and the x-intercept. It's important that you understand that solutions and zeros and roots and x-intercept are all the same thing because different teachers, different videos, and sometimes textbooks will refer to it as something of a different name, but it's always going to be one of these four names. Basically, though, a solution of a quadratic equation is the x-intercepts. This is where the parabola crosses the x-axis. So if I have a graph and it has a parabola, my solutions will be my points of intersection on the x-axis. A quadratic equation can have 1, 2, or 0 numbers of solutions. If an equation has only one solution, that means its vertex actually has fallen on the x-intercept. If it has 0, it would mean that the parabola is either above the x-axis or it is below the x-axis. Here's an example of a parabola. The U-shaped figure. Notice that it does not go straight up, but there's kind of a curve to it. The lowest point is the vertex, and we call that the minimum or the maximum. Here it is going to be the minimum because it's the lowest point on the graph. And then our solutions are going to be right here where the graph or the parabola actually crosses the x-axis. One of the ways that we can solve a quadratic equation to find those solutions or those x-intercepts is to use the quadratic formula. And this is the quadratic formula here. The formula looks pretty complex, but it's really not difficult at all. Remember that the first thing you will do is put your equation into standard form, which would be like ax squared plus bx plus c equals 0, with a, b, and c being numbers, and a and b are the coefficients of x squared and x. You just identify these terms, A, B, and C, and you plug them into the formula. One thing that I'd like to point out about the quadratic formula is this symbol right here, the plus or minus. That's actually creating two equations, and what that means is negative b plus the square root of b squared minus 4ac over 2a. And then the second equation would be negative b minus the square root of b squared minus 4ac over 2a. Part of the quadratic equation is called the discriminant. And the discriminant is going to be the portion underneath the radical sign. And in this previous slide, the discriminant would be this portion right here. It's not with the radical, it's without the radical, just b squared minus 4ac. The discriminant is an important piece of the quadratic equation because it's going to tell us the number of solutions that we will have in the quadratic equation. So the number of solutions is determined by the answer that you get with the discriminant. Again, you're going to get these values B, A, B, and C from the actual equation when it's written in standard form. There are three different answers that you can get using the discriminant. The first answer is whether you have a no solution. You can, by looking at the discriminant, you can determine that the equation has no solution. Here is my discriminant. And that is, that negative 3 is after I simplified the b squared minus 4ac of the equation. So I'm telling you that it is a negative 3. And if underneath the number under your radical sign is a negative number, then the answer has no solution. So if you want to know if there's no solution of an equation, a quadratic equation, the only thing you really need to do is put it into this formula right here. And if you get a negative answer, you'll know that that's supposed to be a negative number under the radical. Therefore, there's no solution. Sometimes when we calculate the discriminant, we'll come up with a number 0. And in that case, 0 would indicate that the number will have only one solution. So when you calculate the discriminant, if you get 0, that you know that you only have one solution. And this is why right here is because the square root of 0 is 0. So if I go from here to this next expression, negative 2 plus or minus 0, it doesn't matter if negative 2 is plus 0 or negative 2 is minus 0. I'm still going to get the same sum, which is negative 2. And then I have, it's going to equal negative 1. So any number with the discriminant of 0 will always result in only one solution. Now sometimes we're going to get answers that are not negative and not 0, and this would indicate that there will be two solutions for the rational. And both of them will be rational numbers. And actually, let's see. And then if the numbers under the radical is a perfect square, then we're going to have no solution. And actually, these notes are just a little wrong because it says both are rational numbers, no radical. But this portion right here should not be on there because that's not true. If the number under the radical is not a perfect square, then you are going to have a radical answer. And that means you'll have a radical in your answer. So perfect square would mean you can eliminate your radical, so you would have no radical at all. And if you don't have a perfect square, that means you'll have a radical in your answer. Now we're going to take a moment and look at these two concepts or the ideas of if the discriminant has two solutions. We're going to look at those separately. The first thing we're going to look at is if the number underneath the radical is a perfect square, and that would mean that you're going to end up with no radical left. Remember that we will have two answers if underneath the radical is a perfect square. And the reason is because we come up with two separate equations. We start off with negative 2 plus the square root of 4 over 2. But we also have negative 2 minus the square root of 4 over 2. This, of course, will simplify to be negative 2 plus 2, because the square root of 4 is 2, over 2. And then we will have negative 4. I'm sorry, we will have 0. Let me erase that real quick. We'll have 0. Negative 2 plus 2 is 0 over 2. So our first solution is 0. And here we will have negative 2 minus 2 over 2. And we'll have negative 4 over 2. And negative 4 divided by 2 is negative 2. So our solution, if we had an equation and we plugged these numbers into the quadratic formula, and we had a discriminant of 4 once we calculated that b squared minus 4ac, we're going to end up with two answers, and those two answers, after we finish the quadratic formula, will be 0 and negative 2. Now, if the number under the radical is not a perfect square, we're still going to have two answers, but we're going to end up with a radical answer. So if I had a quadratic equation and I plugged all of the information into the quadratic formula, and as I simplified, this is what I ended up with, negative 2 plus or minus the square root of 3 over 2. I actually have two equations here. I have negative 2 plus the square root of 3, and I would have negative 2 minus the square root of 3. Oh, I'm sorry, this is over 2, and this 2 is over 2. So here I have two separate answers because I would have a negative number under the, I'm sorry, I'd have a non-perfect square underneath the radical. But I do not need to break it up like this. I do not need to write my answer as two different answers like this. I can just leave my answer with the radical. So I would just write it negative 2 plus or minus the square root of 3 over 2. You need to remember that these are two separate answers, but there are two separate answers here, but you can write it as one number. What we're going to do right now is we're going to start practicing identifying your A, B, and C, and then start working with the discriminant and see if we can determine the number of solutions an equation will have. So here we have three quadratic equations, and we need to identify the A, the B, and the C. My A here will be my number in front of x squared, so that is 3. My B is the number in front of my x, which is 2. And my 4 is the constant. You need to remember, though, when you're looking for your constant, you must have a 0 here. If you do not have a 0 on the right-hand side of your equation, you need to move all your numbers to the left-hand side so that you have a 0, and then determine your A, B, and C. Here my A will be 4 because 4 is the number in front of x squared. Here my B value is a negative 1. And as you remember, we always have a number in front of the variable, even if it looks like it's not there. And because we have a negative sign, makes it a negative 1. A C is 5. Here, just like the equation previously, if we have an x squared, there's going to be a 1. So our A is 1. Our B is 5. And our C is 4. Now that we've practiced finding our A, B, and C, we can actually look for our numbers as solutions by plugging into the discriminant property. So what we're going to do right now is we're going to start off by identifying our A, B, and C. Then we will use our discriminant property to determine the number of solutions that we have. And as you recall, the discriminant is the b squared minus 4ac. So in this first example, example D, I need to identify my A, B, and C. My A will be 1. My B is negative 7. And my C is going to be negative 8. If I plug it into the formula, it will look like this. Negative 7, make sure you put that in parentheses so that you square both negatives, minus 4 times my a, which is 1, and my c, which is negative 8. Negative 7 squared is a positive 49 minus negative 4 times negative 8 will be a positive 32. 49 plus 32, that is going to be 81. So I'm going to have 81. 81 is a perfect square. So if I have a perfect square underneath my radical, that would mean I have two solutions. In the next problem, I'm going to do the same thing, identify my a, b, and c. So my a is 4, my b is negative 12, and my c is 9. Plug it into the discriminant. So I have negative 12 squared minus 4 times my a, which is 4, and my c, which is 9. Negative 12 squared is going to be 144. And then I'm going to have my negative 4 times 4 times 9. So I'm going to start off with just multiplying the 4 times the 9, which is 36. And 36 times 4 would be 144. So that's going to be minus 144. Oops, that should be a 4. 144. 144 minus 144 is 0. And as you recall, any discriminant that is 0 would indicate that we only have one solution. In our very last example, we have a is 1, b is negative 5, and our c, oh, I didn't even notice that at first, so let me go back just a second. If you look here, I have a c. My c is on the right side of the equal sign, so I'm going to need to move that over before I can even get started. So we're going to back up just a second, and we need to add 9 to both sides so we can get that negative 9 over. So I will have x squared minus 5x, because I cannot add negative 9 to 5x, and that would be plus 9 is equal to 0. So again, if you do not have all your numbers right or left of the left of the equal sign, you're going to go ahead and move that over. So my a will be 1, my b is still negative 5, and now my c is a positive 9. I plug that into the equation and I have negative 5 squared minus 4 times a, which is 1, and c, which is 9. This is going to give me a positive 25 minus 4 times 9 is 36, so minus 36. 25 minus 36 is going to be negative 11. If I have a negative number underneath my radical, my discriminant, that would mean I have no solution. So this answer would be no solution. So this is just an introductory lesson to quadratic equations, and we will continue to learn about quadratic equations and how to solve them. And the formula is just one of a few ways that you can use, methods you could use to solve it. The one nice thing about the quadratic formula is that it works on every single equation. The other methods sometimes are easier than the quadratic formula, but they don't necessarily always work. So you have to be very careful that you pick one that's going to work for the equation that you have. The most important thing that you need to remember is that you have to move any number that's right of the equal sign over to the other side of the equal sign so that you can have your numbers or your equation in standard form to identify your a, b, and your c. And then you're simply just going to plug those numbers into the formula. Today we only worked with the discriminant, but later on in this unit, the next lesson and the lesson after that, we will be actually plugging into the entire formula and then coming up with the solutions for the quadratic equations.